Thank you for coming to the last session of the day. Hopefully you are all feeling awake and have enjoyed the first day here at BriForum. As you said, my name is Dan Brinkmann. I'm a solutions architect. Essentially that means I'm a pre-sales engineer for a partner in Denver, Colorado called Luana Associates. Unless you are from Denver, Colorado, you have never heard of us. But we're a VMware Premier and a Citrix Platinum partner, which creates an interesting relationship depending on whose solution we are selling. But what it does give us is kind of, I think, a unique view into, and not to say VMware view, but a unique view into what both solutions are offering. We've done large deployments of both Zen Desktop hosted Win 7, Win XP, as well as VMware View. So, and I'd say that, what I'm going to talk about here today really is not unique to either one of those two solutions. It really is common, and it's really more of a technical focus, although I'm going to hit on a few business points up front as far as what I see or how companies are failing to implement desktop virtualization or VDI in their environment. The other thing I'm also not talking about in this session is anything related to a shared or a TS environment versus hosted virtual desktops, VDI. I'm kind of assuming at this point that if you were at this session, you have decided that you might be ready to deploy VDI in your environment. Although there might be other ways to do it, this is just talking about VDI, although many of these things will also relate to TS, things like that, where we're sharing multiple users on top of a single OS. I have my Twitter handle up there, D Brinkmann. I did a blog post last week, actually, about Twitter, and I say this at every event that I speak at because, for me, Twitter has really significantly changed my career, and I talk to a lot of people locally in Denver, that are in the IT community, as well as people that attend these, trying to basically tell them, how I use Twitter. A lot of people I've talked to said, well, I used it, once 3 years ago, and the content that was on there really wasn't of interest to me. It was, people talking about their bathroom habits or where they were having lunch, and I agree that's not interesting to me either. But I did a blog post. 2 weeks ago, I was at Citrix Synergy, and I used to attend Microsoft Tech Ed back in the States, did that for about 8 years. And kind of my typical behavior was I would go to Tech Ed, I'd maybe talk to a couple of people at breakfast that were sitting at the same table as me, maybe talk to a couple more people at lunch, but for the most part, remain mute for an entire day, go have some drinks, go back to the room and pass out. And I thought that was a pretty good, it was pretty good technical content I was getting. I enjoyed my time, I enjoyed the drinks, and I think a lot of us in IT are naturally introverts, so that fit me quite well. But what I realized in going to Citrix Synergy a couple weeks ago was it turns out that I knew about 50 people there. About 40 of those people were ones I had met on Twitter. Some of them I had met previously, and a lot of people I was meeting for the first time. And so I was going to sessions, and I was getting information from those sessions. But more importantly, what I realized is I was getting even better information from the other people who shared a common interest as me, that I had spoken with on Twitter or tweeted with. I've even had people tweet me their phone number and called them up and asked them questions. So for me, it really it clicked, right? It was hey, Twitter for me really now is a business tool. It's something I use to find others that are interested in doing or are doing the exact same thing I am, asking them questions, getting information, getting their view on where they think the future is going. And I can tell you without a doubt, if I didn't have a blog and if I wasn't on Twitter, I would not be here right now. So I'm not sure where each of you are trying to take your own career, but I think even from just a technical perspective, the amount of information that's on Twitter, I know in talking with many of the speakers here at BriForum and the ones at Citrix Synergy and Summit, that nearly all of the presenters are on Twitter. So I always tell people, I'm like, okay, you guys all paid money to come here and listen to people speak about some technical topics. Well, all these people are available on Twitter, and many of them are very responsive to questions. So that's my plug for, I guess, why I use Twitter. And maybe you'll find it useful. Maybe you'll check it out, kind of see some of the hashtags out there about BriForum this week. I'm going to be posting these slides maybe tonight if I have some time on my blog. So please don't worry about trying to scribble down like a URL or two that I have in here. It will be available, and I know that Brian's making all of these sessions available as well. Interestingly, I'm a VMware vExpert. I do mainly, when we talk about desktop virtualization, much more Citrix than VMware, but from a hypervisor perspective, probably like many of you, we do a lot of VMware vSphere as the hypervisor, even if it's a Citrix or definitely with VMware View environment. So that's my background. That's what I focus on. I do a little bit with things like Xen Server, no Hyper-V. Sorry if I'm offending anyone about that, but that's what I see in Denver. So we're here to talk about how to fail at VDI, and I think more importantly, my goal really is to educate you about some of the technical failure points that I see. And I always feel like if you understand what I know, then hopefully you will understand why some of the things that people are trying to do with VDI are challenging at best, and in some cases just not possible. And so you can best position this within your own environment to succeed. I don't think anybody goes into this hoping that this isn't going to work. So like I said, I've got a couple slides here that really talk more about some of the business issues with VDI. And I meet with, on average, probably at least 3 customers a day, and just really on virtualization, and most of the time it's on desktop virtualization. And this is the first statement that I start with when I go and talk to a customer is, what's the business problem that desktop virtualization is going to solve for you in your environment? And I'll bet you at least 25% of the time, they have no answer whatsoever. Another 25% of the time, their CIO has told them that they need to look at this. And the other 50% of the time is some other random answer that really makes no sense. Maybe there's like 20% of the time that maybe they have maybe some decent reason that we can start discussing. But I really think that this is really the most important thing that people have to start with, which is what is the problem you're going to solve with VDI or with desktop virtualization. And if you don't have a good reason to start, if you don't have a business problem, then while it's a great intellectual exercise, it's just that it's not going to go anywhere in your business. So back to business and what I call expectation level failures. No business problem really is the first one, and I keep hitting on it, but it really is true. It's not a fit for everything. People that do this as a career, I think, know that, and we just need to find what is the right fit for VDI in an environment, and maybe there isn't a good fit for you today. The other thing that I find that is, I think maybe you hear it, but it's still misunderstood, which is that, and I think Brian also talks a lot about this, which is desktop virtualization is not like server virtualization. The only common thing is that it's on top of a hypervisor, but there are so many differences, just from the fact we are removing a physical PC from under a desk and putting it into a data center, that we are, remoting, USB ports and things like that, that it's really unfair to say that, well, we were successful with server virtualization, therefore we will be successful with desktop virtualization. There really are a lot more complexities to it. Saving money, I know this gets talked about a lot, so I'm not going to talk about it really at all, other than I never sell VDI as a way to save money, even if I think they can. It's just, for me still, it is a rare day that they are going to save CapEx, and in many cases still OpEx, by doing VDI. And just like Brian, let's be clear, I do love desktop virtualization. I just want people to focus on the things that's going to make them successful in doing this, and not on the things where I see people failing. I don't write this next statement to offend anyone in the room. I myself, I think I consider myself a vSphere administrator, or at least I used to before I did more desktop virtualization. What I really mean by that is I meet with a lot of companies, and the person driving the project, and really one of the key people or a key person that's driving the project is the vSphere administrator. And I think that in order to be successful in a desktop virtualization solution or in VDI, there really are so many other aspects to it that the larger the organization is, the bigger that group of people that's driving the solution needs to be. And if it is just the vSphere administrator who is in charge, your company probably isn't that committed to actually doing this. And so I think that's really my statement around, if you're talking to just the vSphere administrator, he's the one driving the project, I usually see that as an area of caution for me in proceeding. Yeah, it's warm in here. And then no success criteria, right? So what are we actually trying to get out of, back to the whole, what's the business problem we're trying to solve? What success criteria are out there that we're trying to test out in deploying a VDI project? This kind of relates back to the vSphere administrator, assuming what you know what your users want. I started out my career in desktop support. Once I got on the server team, I can tell you I had no intent of ever going back to the desktop. And in many cases, the people that are vSphere administrators share that same philosophy. So if you're not willing to talk to your end users, then you're probably not going to deliver a solution that they're looking for. And then surprisingly, this comes up more and more, which is people have this expectation that the remote user experience with VDI should be as good or better as the local experience. And I find it strange that people are asking for that. I understand that they're asking for it, but I find it strange that people actually think that that's possible. And we're going to dig into some of the reasons why I think VDI can be challenging, and hopefully you'll understand how to, what are the warning signs to look for, and how to better look at the environment from a compute and storage and tools perspective. So our agenda today is really to talk about, to understand from a compute, storage, and tools, or guessing, what I call, with lack of tools, understand how these different things work, how to do planning around it, how to, once you have it in production, how to address, doing change management to that environment. I don't know, do you guys have The Simpsons over here? I assume you do, right? I thought that was a good one. Trying is the first step towards failure. If you're in the back of the room and can't read that, I thought it was funny. So we're going to talk about kind of what I see as causing VDI failures. And this is just basically directly from the customers that I work with on a daily basis that are doing this today. So the technology failure points that I see, and I think you'll understand why these are technology failure points once we dig into the compute and storage layer, is I see a lot of people that are testing out VDI solutions and they're doing it with 5 users. And 5 users is not scalability testing, it's not performance testing. It many times doesn't even scale linearly. Things that work with 5 users don't work with 100 users. And we're going to dig into that a bit more today as well. Working for a reseller. We sell, Dell solutions, HP solutions, NetApp solutions, most of the manufacturers that are out there, and that's where a large percentage of our revenue comes from, as well as services around the implementation of that. And I can tell you that the vendors that are designing and providing you benchmarks on number of users or virtual machines per core you're going to be able to do in a VDI environment, or the amount of IOPS that your desktop is going to take, I can tell you, at least in the region I'm in, those vendors, for the most part, are completely clueless. They are simply passing down marketing material to you, and it really, I don't know that they are essentially, all that invested in your success. And I think that you guys really need to take, the initiative to, determine what that number is, how many VMs per core you're able to do, how many IOPS per desktop you're going to have, because every environment is unique, and vendors ultimately, their numbers are not based on, your application sets. See a lot of people still ignoring antivirus. We'll hit on that a little bit later. I know there was an AppSense session, I think the one before this. We got RES Software, AppSense here this week, Liquidware Labs. Understanding how profile management, streamed apps, things like that also impact your storage I/O numbers, and when it's going to hit the storage, right? It might not be when you expect it. It might be during certain peaks, like users coming back from breakfast that you might not be planning for. I still see a lot of people that are using desktop PC images in the rush to deploy a pilot or to deploy a solution out to users. And because many times it's the vSphere administrator, they simply suck in the existing desktop image and try to deploy that into a VDI environment. We'll talk a little bit about why that is. I think it's pretty self-evident, but why that can be so bad. And ultimately, what I find many companies doing still is guessing at all of this information. That it's just a complete guess into the air as far as how many users per host they're going to be able to do, how many IOPS per desktop, and where those IOPS at the OS level are coming from. And when we're guessing, we're typically adding a lot of risk to the project and a lot of cost, because we're overestimating, or in some cases underestimating, and then they're going out to production and unable to sustain the load of the number of users they're trying to put on the system. So the compute layer, CPUs, right? It's, I think from a server perspective, the good news is that the servers that people are buying today to do server virtualization are so powerful that for a lot of organizations, the kind of the mid-sized organization, for the number of servers they're putting on these hosts, they're not even touching the amount of capacity that are in those systems from a compute perspective. And so there's really no way they can fail. But when we start doing VDI, we're really talking about pushing those hosts much harder than they're being pushed today with server virtualization. And there are things Excuse me. There's an expectation, I think, from a lot of people that we're going to be doing single virtual CPU VMs when we're doing hosted virtual desktops, or VDI. And what if you've obviously all been around for a while, but Intel a number of years ago said, hey, we're not going to make these CPUs faster. We're not going to keep cranking up the megahertz and gigahertz. You need to multi-thread your applications. So application vendors, as they write new applications, have been multi-threading their apps. Cisco and VMware, or Citrix and VMware included. And yet, when we deploy VDI, in many cases, we're trying to do that on top of a single vCPU VM. And so I think there's a difference between what application vendors are doing and what you're trying to deliver using VDI. And so what I see very quickly on the horizon, at least with our customers, is that people are moving from this single virtual CPU model to one where they have multiple virtual CPUs in order to deliver a good user experience for applications, both productivity applications, as well as things that are latency sensitive like multimedia. In order to do things like render rich content, video, audio, then convert it and encode it and ship it onto the wire, many times that takes more than one virtual CPU. And if you have ever done any testing with this, you know that 2 virtual CPUs on a VM delivers a significantly better user experience than a single virtual CPU. Unfortunately, that creates some contention at the compute layer as it relates to VDI. And then hyperthreading. So I use the description for hyperthreading like this because I think it's a misunderstood technology. So hyperthreading is basically creating 2 logical processes or processors out of a single physical core. And so I usually tell people, I say, well, basically the physical core is the checker at the supermarket, and hyperthreading is the conveyor belt. And so, while the person in front of you is getting checked out, doing work on the physical core, you're able to put your groceries onto the conveyor belt so that as soon as that workload is done, they can start, ringing you out. And so that process, you're basically taking threads, you're retrieving things from memory, from L2, L3, or physical RAM, and getting ready to do the work. So it definitely increases performance in environments, but we need to understand that does not equal a physical core. And ultimately, at the end of the day, we're only dealing with physical cores, not logical ones, because that's where work has to be performed. And that in the compute layer, many times I think we've been, ingrained to think that CPU compute, that the measure we're looking at there is utilization, and I think that's inaccurate. What I found in server virtualization environments, and definitely in desktop virtualization environments, is that it's really about the latency between virtual CPU and physical core that in many cases is where the contention on the compute layer is occurring long before utilization hits a number that you would normally be concerned about, whether that's 80% or 90%. So I think it's good that we talk about this so you understand where to look, and when you're doing things like multimedia, things that have multiple threads, where that contention is going to occur and how you can do a little bit of troubleshooting. So a little bit about the CPU scheduler in vSphere. Windows, Unix systems, they use a priority, right? So threads get spun up, they have a priority. Threads with a higher or lower, however you want to look at that, priority can preempt threads that are less important. Well, I think people believe that that's the way that maybe the vSphere scheduler works. And in fact, it doesn't work anything like that. There is no priority within the vSphere scheduler. And I'm talking here just about vSphere because this is what I see 80+% of the time as the hypervisor in these solutions. But the way that the scheduler within vSphere works is it's based on shares. So if you're doing resource pools, or if you just let every VM fight for itself, you're basically allocating equal shares from a compute layer to the virtual desktops, the VDIs that are on that host. And what happens is that vSphere is looking at the shares, the entitlement to that virtual machine, and then looking at the consumption. And in fact, the more that a virtual machine consumes, the more likely it is that if another workload needs the physical cores, that it will preempt that other virtual machine. So the more that you use, the more entitlement you use, the more consumption you have, the lower basically priority that you have on the actual physical cores. And so we start talking about things that are latency sensitive or that are CPU intense, right? And if you have a lot of virtual machines fighting for that scheduler, for that physical core, I mean, fundamentally the scheduler is not based on priorities. The priorities that exist within Windows are not magically given down to the processors or down to the vSphere hypervisors. vSphere does not have any clue, other than what Windows is asking for to be processed first. that this is audio or this is video, or that you're watching an audio or a webcast and this person is using a word processing application. So I think if people understand how that scheduler works, it becomes very clear that we could very quickly get into an ugly space if we have a lot of virtual machines sharing a limited set of physical resources. So where I think this becomes pretty self-evident is, this is your physical PC, right? This is maybe a Core i5. If you had a hyper-threading enabled, you'd have twice as many logical processors. Sits on your desk, maybe it's a laptop. But this is what users are using today. And the operating system is able to basically directly almost schedule work on those processors using its priorities, right? It's not being preempted by anything else other than what Windows thinks is important. And this is sitting under a desk, right, or traveling around with you. And then we go into the let's say the TS world or the Citrix XenApp world. I know a lot of people are still doing physical terminal servers for those that are doing terminal servers or XenApp, but we do a lot of virtual as well. And the guidance that we give our customers, as well as the guidance from Citrix, is to not over-allocate physical cores on the server. So if I'm using, for example, some of the new 8-core systems that are just coming to market for this example, and in a real-world example, you'd have a physical core that's really just there for the hypervisor itself. But you can see that we're really just mapping logical virtual CPUs on a one-to-one basis down to the physical cores, right? So that there's really no other virtual machine that is going to be preempting the processes that are happening here at the hypervisor level. And then people make this jump and say, oh, whoops, I'm going to do VDI, right? So we went from this, one-to-one to this, many, many, many virtual CPUs to limited physical cores available on the hypervisor. And this is where I see things getting in trouble. And I've got like 200 virtual CPUs up here. Maybe you have 100. But I think that people have some very high expectations of how many virtual CPUs they're going to put on to a limited number of physical cores. And this is where, based on things like the CPU scheduler within vSphere, things go awry. So back onto the how people do performance monitoring on the compute layer of vSphere. We do seminars in Denver, a lot on just server virtualization, a lot on how to do performance monitoring. If you're a vSphere customer, you're probably looking at things like VCOps, pulling more statistics out of maybe ESXtop, or maybe you have some third-party tools from like vFoglight out there that are pulling some of this information. But I still see a lot of people that are using the host tab of their vSphere client as the measure of when their ESX or vSphere hypervisor is taxed. And I think that if that number is 100% memory or 80% memory or 90% CPU, that's probably a good indication you're out of resources and it's time to plan an upgrade. What I find is that both in server virtualization and definitely in VDI environments, that contention is occurring at the compute layer long before the utilization level ever reaches a level that you would typically be alarmed about. Okay, this thing's sticking. So what I typically encourage people to do are use things like ESXtop. Maybe you have automated tools in your environment that are getting some of the same information. Maybe you don't, but you all, if you are using vSphere, have access to ESXtop. And this is really what I direct people towards, if nothing else. And I think that values like %ready are a much more accurate way of determining whether you have contention from a virtual CPU to physical core in your vSphere hypervisor. So %ready is the amount of time that a virtual CPU is waiting, basically in queue, for a physical core to become available. And these threshold values, this is published on multiple VMware websites, and I can tell you from my own experience, around 10 is that number. If it goes over, basically, if it's waiting more than 10% of the time, you're going to start to notice that as a poor end user experience, if you're delivering a hosted VDI desktop to someone. So if you think about also where I talked about with like multiple virtual CPUs, multi-threaded applications, the second value here is %costop. And %costop has to do with how much time the CPU scheduler is basically halting a virtual machine's progress in order to co-schedule workload. And vSphere does what they call relaxed co-scheduling. It used to be that 2 physical cores, if you had 2 virtual CPUs, had to become available at the same time in order to process that workload at the same time. They can now do that more asymmetrically and handle the skew between when one workload is processed on one virtual CPU and when it's processed on the next virtual CPU. But it's still highly likely that if you're doing 2 virtual CPUs in a VDI environment, that you're going to start to see percent co-stop values creeping up. And that percent co-stop is then also going to be impacting the percent ready values. And percent ready being really the health of your environment, the latency that virtual CPUs are experiencing as they try to process physical work. And anytime when you are trying to do things, this is why we don't do soft phones on top of a VDI solution, at least not at the scalability numbers that you want to do it at, is that we have limited physical resources. When this percent ready value goes up, your audio stops, right? And so it's a poor user experience. But if you're using these values, I think that this is in conjunction with utilization. Like I said, I don't think you should ignore it completely, but I think that ultimately this number is much more important and useful to me in understanding whether you have tapped the amount of resources available at the compute layer in your vSphere. So if it says 20% and you've got a high percent ready value, maybe because you've got a lot of virtual machines, a lot of maybe it's 10 to 1 virtual CPU to physical core overcommit, you're done, right? That's what it is. You need more physical cores available to process that workload. And there's another one on here, percent sys. If you have VMs that are doing a lot of I/O, probably not going to see that in a VDI environment, but that's another one to pay attention to. But really, percent ready and percent co-stop are the values that I use in trying to determine whether we have a compute bottleneck. So I've got an example here, and I realize that probably anybody farther than 2 rows back is not going to be able to read this. But it's just kind of an example we were doing in our lab, basically showing high percent ready values. Ultimately, the percent CPU utilization is fairly low, and the amount of actually workload being done is fairly low. So it's not what you would typically, if you were to look at this from the host tab, or you were to look at this from a CPU perspective at the VM level, you wouldn't see high CPU utilization. But if these were desktops, and some of them are, what you'd be seeing, at least from an end user experience, is that virtual CPU is waiting a large amount of time for physical cores to become available. I think my battery's going dead. Sorry, my voice is going. I think I screamed too much at the bar last night. This is an example here just showing percent co-stop driving a high percent ready value. Percent co-stop in this case is 73 point something, and percent ready is 166. It's waiting a long time. If you were this were a desktop, you would be experiencing a really crappy user experience. And at the end of the day, the percent used is it's 249%, and that's based on the number of virtual CPUs and the workload being performed. So here we actually dropped the number of virtual CPUs. We're doing a little bit less work, but our percent ready value has dropped off. So this is not only relates to desktop virtualization, but also server virtualization. So kind of a summary on compute and where I see issues occurring. I think that we go into VDI thinking that we are going to do single virtual CPU VMs. The reality that I see more and more often, and I think it's something that you need to determine up front, is that people are using multiple virtual CPU virtual machines to take advantage of multi-threading, not just for multimedia applications, but also for productivity applications that are in your environment. And if you're an application developer, or if you have application developers in your environment, your application developers are writing multi-threaded applications because that's what they've been told to do. So in order to increase the performance of any of these applications, you're going to have to start adding multiple virtual CPUs to these VMs. And that's going to cause contention. That's going to, you're going to have 10, maybe more, right, virtual CPUs to physical cores, maybe less. It really depends on what you're trying to do in your environment. But if we're not digging in at that ESX top layer, if you're running a vSphere environment, if you're not looking at percent ready values, you're probably going to be unaware that there is a CPU bottleneck by just looking at utilization numbers. The fact that the scheduler is not priority based, fundamentally this I think is an aha moment for a lot of people, which is, okay, the more work that this VM asks for, the more likely is another workload is going to preempt its task, take away its physical core, and do another task. So when you think about things that are latency sensitive, multimedia, audio, video, that's a really big deal. Utilization is not the complete picture, and ultimately, in my mind, and with the customers that we are working with, the more important number in determining when your compute layer is saturated is latency, and that would be the % ready value. And then I've got a link here, and this will be more useful when you have the actual PowerPoint itself, which is it's a link back to the VMware website where they talk a lot about how to do performance analysis and troubleshooting for CPU, network, memory, and disk. And I think that's if you're doing it on top of a vSphere hypervisor, that's really important to understand, because ultimately what people are doing in VDI, they're pushing that server significantly harder than what they're pushing it within a server virtualization environment. So, storage. Back to a little bit about server virtualization, but the number one issue that we see when there's a performance issue is that people have a storage bottleneck. And unsurprisingly then, as people move to desktop virtualization, the number one issue that people have is storage. In fact, I can tell you that all of our customers who are doing hosted virtual desktops have dealt with storage bottlenecks on their system. Many of them went into this, and we're going to talk about it later, which is they went into it guessing as to how many IOPS they were going to need. They all guessed wrong, and they all had bottlenecks. They all had more IOPS that were required from their virtual machines. They all had spikes and peaks they were not expecting, and they all end up spending more money on storage, and they've all had contention at the storage layer. So I think it's really important to understand how storage works, how RAID penalties work. I know that there are a lot of vendors here this week that are talking about SSD solutions, optimizing I/O that help us get more IOPS out of spinning disk. But ultimately, the same rules still apply, whether it's SSD or not. The benefit of SSD is you just have so many IOPS, just not a whole lot of capacity. And again, in the storage world, regardless of what a storage manufacturer tells me, at the end of the day, I really don't care what magic they did. What I care about is that my requests for reads and writes are satisfied within a specific time period. And so, this might vary a little bit in environments, but typically anything over 20 milliseconds, you're going to see that from an end user perspective. Anything over 50, your phones are lit up, and your users probably hate you. I've got customers that even have a couple hundred milliseconds because they significantly undersized the amount of IOPS that they thought they would need in guessing as to what they thought their desktops were doing. So I actually stole this. The wrath of the math. It was somebody else tweeted that out. It was Jason. I can't remember if I pronounced his last name right, but it's Langoni. Works for Nutanix. I just thought it was a clever little quip. I'm just going to use this. So what we need to know when we're doing desktop virtualization is it's a balance of capacity and performance. If SSDs were 1 terabyte in size and cost the same as a spinning disk, we wouldn't be talking about storage right now. We just tell you, go out and buy a whole bunch of SSDs, and it'll work. There's so many IOPS there that are excess of what you actually require in VDI that there's no way that you could fail. But the reality is that SSD is still very expensive. Typically, people are still unable to get the capacity numbers that they're trying to get using even local SSD. So we're combining in some cases SSD and spinning disk, but ultimately what we're still having to do is plan and understand what the I/O profile of our virtual desktops looks like. Important to understand that random IOPS is what you're going to see in a VDI environment, and random IOPS are really decrease the number of total IOPS that your disk are going to be able to do. There are some vendors out there that are doing storage optimization. They're doing it with spinning disk. The way they're able to do that is they're doing things like coalescing the I/O and writing data sequentially to spinning drives. They're making that data sequential versus random and able to extract a lot more I/O performance out of the same spinning disk. I'll just tell you, in your VDI environment, it will be random unless you do some sort of optimization. So we just use generally the low numbers on disk drives. Averages versus peaks. So this is an area where many times we're planning for that average number, but we also need to understand what the peaks are and when they're going to occur. This is I found is very different for different organizations. Might be based on everybody takes a lunch break at the same time, everybody takes a break at the same time, people all are required to be at work at 8 a.m. But we need to understand, not so much, I don't worry as much about the boot storms as I worry about login storms, worry about storms that are caused maybe by streaming applications to virtual desktops. and other things that might be unique to your environment. But we need to know both the average number as well as the peak. And then, unlike server virtualization, where the workload is, you pretty much know what it is. It's like, that's my Exchange server, that's my SQL server, and you really don't care where it's coming from within that operating system. You know that, well, it's SQL and it generates this much I/O. Within the desktop virtualization or VDI world, it's very important that we know where it's coming from. And this isn't something that people typically know with their physical desktops, because we didn't need to. It was, everything that happened was isolated to a physical machine, and if it ran slow, it didn't impact other people, and it typically didn't last that long. But when all this is consolidated in centralized storage, it creates much bigger problems. And because people don't have tools, we end up guessing. And this is where I think we get into a lot of trouble. This is where I see most of the trouble coming from, is the fact that we don't actually have actual data. So if you go out on the web, you'll probably find, these are kind of a consolidation of other places that have posted this information. Every test that, if you were to go and test this in your own lab, if you're doing random versus sequential, these numbers are going to come out very different. But this is what I generally use as the numbers when we're doing sizing. And so we're going to talk a little bit about how we plan the number of IOPS that you're going to get out of your array based on the speed of the drive, the RAID type you're using, and then the read-write split. So 7,200 RPM drives, SAS, SATA, this is actually a little bit dated, but 75 to 100 IOPS. But it's really going to be dependent on random read, random write, things like that, the caching controllers that sit in front of this. 10,000 RPM drives, 125 to 150. 10,000 RPM SAS drives, probably about the same, about 150. 15,000 RPM SAS drives, 175 to about 210 IOPS. And definitely these numbers vary a lot. I've seen some environments that are able to get 400 IOPS out of spinning disk, and some companies that are doing significantly under 100. Really just comes down to what that workload looks like. So this is one aspect to basically planning and doing the math on what are the total number of IOPS that our system is going to provide. The next part, I know when I was first getting into IT and doing desktop support, I read things that said, well, you should put logs on RAID 1 and RAID 10, and you should put data on RAID 5. And at the time, I really didn't think anything of it. I said, okay, I'll remember that, and I'll do that. But I didn't understand the why behind it. And this is the why behind it, is because ultimately we have a RAID penalty. And so in doing the math, we take the number of drives we have, and we have to figure out whether we are doing RAID 5 or RAID 10, and then we have to figure out what that read-write mix is. Because as you can see, for reads, there is no penalty, right? It's just the raw number. So if you're doing 500 reads, regardless of the RAID type you choose, it's going to be 500 reads from disk. That is not the case with writes. And so if you are trying to do VDI, and typically VDI is a very heavy write I/O environment. We're going to talk about that in a little bit. And you're using something like RAID 5, 500 read IOPS turns into 2,000. I'm sorry, 500 write IOPS turns into 2,000 write IOPS, in addition to any other read I/O that's being done. And RAID 6 is even a bigger penalty. And so this information, along with the drives that you're using in your environment, has to be factored in to determining kind of what's the total available I/O from your array, whether that's local disk, whether that's shared SAN storage. Like I said, this doesn't really take into account things like caching that are going to occur at a controller level or I/O optimization. But this is really the raw of what's available within the storage system. And what I've found is, we've actually got a 2,000 seat view deployment that does a lot of write IOPS. They thought they would have their storage controllers cache this write I/O. What they didn't calculate in behind all this is that the amount of write I/O they're doing overwhelms the storage controller. The physical disk behind it can't keep up. Right? They were just worried about these spikes. What they didn't understand is that those spikes translated to so much data. It filled the cache on the storage controllers, caused a cache flush, and now they were just basically bound to how fast the spinning disk could do write I/O. And because of the RAID penalties, it was significantly less than what they had thought or what they had planned in working with their storage vendor, because they ultimately didn't understand how many write I/Os were going to come out of the environment, what the total size of that write I/O was, and where they were going to land it. So a little bit about the math, right? So I'm taking an example here, and I use 500 users because Denver is a location where we don't have a lot of really large organizations. We don't have like a lot of 10,000, 20,000 user organizations. But we've got a lot of organizations that are between that 500 user and 3,000 user size. And so I go into a lot of organizations that are, say, about 1,000 users in size. And they're going into it thinking, well, I'm going to do 500 desktops of VDI. And I start out, kind of doing this math with them so we can start talking about storage, so they can understand the impact of storage in their environment. So 500 users, Windows 7. I'm using 20 IOPS as the average. Like I said, every environment's going to be a little bit different. A 50-50 read-write mix using RAID 5. Right? Maybe this is a customer that doesn't have a lot of shared storage. Organization of maybe 1,000 users probably doesn't have a huge server environment. It depends maybe on your industry. And they might just have a single, shared storage SAN in their environment that was never, designed with VDI in mind, and it's RAID 5 across the whole thing or something. So our 500 IOPS, or 500 users times 20 IOPS per desktop works out to 10,000 IOPS. 50-50, which we'll talk about a little bit more, which I think is pretty aggressive. I don't see a lot of environments that do a 50-50 read-write mix. It's usually much heavier on the writes. But let's say it's 50-50. You've got 5,000 reads and 5,000 writes. Because they're doing RAID 5, that 5,000 writes turns into 20,000 on disk. Add the 5,000 reads on there, and now we've got a 25,000 IOP load. So this organization of 500 users or 500 VDIs that they want to spin up, maybe 1,000 total users, I tell them, if you're using 15,000 RPM spindles, you're going to need 125 of them. And typically the response is, well, that's 4x what I have for the whole rest of my environment. And that's what spawns this conversation most of the time, which is, we're talking about really big numbers here. It's important that we understand the IOPS, because without it, we're just going to be guessing, and you're going to be buying a really big SAN to handle these 500 hosted virtual desktops. So if we change this up a little bit and we say, all right, well, I understand that the RAID penalty is important to understand, and that I'm amplifying I/O by doing RAID 5, so I'm going to change it to RAID 10. So our 500 users with 20 IOPS still, 50-50 read-write mix using RAID 10. So still 5,000 read, 5,000 write, but instead of multiplying that 5,000 write IOs by 4, we're now multiplying it by 2. So I've got 10,000 IOPS of write, 5,000 read, 15,000 IOPS. Do the math again with 15,000 RPM spindles, 75. So we've dropped 50 spindles out of that solution, but 75 is still a pretty big number. So I don't know that I believe in a 50-50 read-write mix. So let's say we start tweaking that number a little bit and see how the math changes. So now we change this math to 500 users running Windows 7, 20 IOPS average, but we've changed the read-write mix now to be 20% read and 80% write on RAID 10. So basically the same example we had in the previous slide, but with a much heavier write I/O mix. And this, I think Ruben was talking about this morning. This is more in line with what I see in environments, and this is more in line with what he sees in environments. I've talked with a lot of other consultants. This is probably close to, if people are going to guess, this is what I would, probably tell them to guess with. So still 10,000 total IOPS, but now we've got basically 2,000 of those are read and 8,000 of those are write. RAID 10, that 8,000 turns into 16,000 write IOPS, plus our 2,000 read for a total of 18,000 IOPS. What's interesting here is that a lot of vendors are out there talking about how they handle read I/O or how they handle boot storms, and they're talking about read I/O. And at the end of the day, the read I/O in this case is 2,000 out of the 18,000. We're talking about just over 10% of the total I/O is read. So in my mind, I am not nearly as worried about the read I/O coming out of environment. And in fact, because of a lot of the caching that exists on storage controllers or other technologies that exist, like say even at the hypervisor layer, there are other ways for me to offload that. So it's a small number to begin with, and I've got lots of options for offloading read IOPS. But now we're up to, we went from now having 75 spindles to do it with 50-50 read-write mix to 90 spindles. This makes sense to everybody? Okay. If somebody passes out from the heat, I'll stop. We'll revive you. Tools. Yeah. Or you know, I mean, there are manual ways to do it, but ultimately, and I'll go into this in a little bit, ultimately I think that tools are really almost required if you're going to do this at scale, not just for the initial sizing, but to really watch how the environment changes over time, because you're always going to be changing this environment. And if that read-write mix changes, you need to know what's impacting that change and how that's impacting your storage environment. So vSphere storage latency, again, I'm focusing here on vSphere because that's the hypervisor we deploy a lot on top of. But there are lots of places here also to measure storage latency. Most of the time we're just looking at this from the vSphere layer, but you know, do recognize that you can pull statistics from the actual virtual machine itself, or there might be latency all the way up to the application layer. Again, or just to be aware, anything up here, because time is based on CPU cycles, and it is not getting the CPU cycles it thinks. Basically, time is all skewed at the VM level. So anything that's a time-based measurement should be considered untrustworthy. So really your best bet for measuring disk latency is down here at the vSphere layer. And so I use ESX top to pull information here, because while we're calculating these read and write IOPS, at the end of the day, what I care about, because there are things we can't calculate, which is the impact of caching and things like that. At the end of the day, what I care about are these threshold values. As long as my read or write request is being satisfied within a specific amount of time, this is kind of like, you know, service level management, right? If you were good to buy storage as a service, you really don't care what they're using. I only care that you can land and service read and write requests within a certain amount of time. This what's called the GAVG average is a sum of these two things. So typically, you know, you'll mainly just see latency here that's occurring at the array level, but there is also the possibility that disk latency could occurring at the kernel level. I don't see that very often. It's typically just the storage layer that's delaying it, but the GAVG is a sum of those two. So if you're over 20, you have a poor user experience. It's pretty much guaranteed. So when we're building storage solutions for read IOPS, and we're trying to figure out how to maybe handle things like boot storms, which you would see, you know, maybe hopefully at off-hour peaks, or you're trying to handle log-on storms where you're seeing some read IOPS and some write IOPS. There are a couple ways to handle it. One is memory, so we can use things. You know, this is what's been going on forever and ever, which is people or the storage vendors have memory essentially in their controllers, and they cache read IOPS. They also use it for write cache, but you know, that's, since we're talking about read, in this case we're going to be using memory as that read cache. So if you're using like linked clones, essentially, you know, your replica 1 is being put up into that memory layer and being served out of memory, and that's one way of addressing the read IOPS that are going to be coming out of a VDI environment. If you're deploying Citrix solutions, you know, the other place where we would be using memory would be using a technology like PVS, provisioning server, where it's actually loading the parts of the file that are being accessed into memory and serving it out of memory, and therefore caching that data so it doesn't actually have to go down to spinning disk or if you have SSD. So at the host and hypervisor layer, how many people here are familiar with content-based read cache or view accelerator? Anybody? Okay. So starting in vSphere 5, there is a feature added, you know, kind of silently to the stack, which is called the content-based read cache, and its function is to basically, it creates a digest file on a VMDK file, and will then, it's a hash file of essentially the VMDK, and it will load blocks of data into memory. Up to 2 gig of things can be cached on a per host basis. Similarly, Citrix on the Xen server side has a technology called IntelliCache, and it would typically use things like SSD on the local server or even spinning disk to cache frequently read blocks there at the hypervisor layer using local storage. Or in the case of vSphere, it's using CBRC. And then the other option there is vendors like NetApp using things like flash cache, basically loading large amounts of SSD into your storage array and having it function as a larger read cache, or solutions that are doing LUN tiering. So they're tiering up the blocks of data that are more frequently read and addressing the read I/O. But ultimately, as I said before, you know, this is a small amount of the I/O, and this is, you know, typically already serviced by memory on the storage controller. this isn't the big problem in doing VDI. So what I find is much harder and more expensive is really building for the right I/O. And I think that if you're ignoring your profile and application layer, you're probably going to have some surprises, and that might, relating back to how people fail. If you're ignoring profiles and apps, that might not maybe reach some of the OpEx advantages you were hoping to deliver with VDI. But additionally, if you're bringing down roaming profiles to your VDI solution, you're creating a lot of right I/O for each user that logs in. If you're in an environment where a large number of users log in all at the same time, this maybe would be like education and using roaming profiles, you're creating a lot of right I/O all at the same time. And because it's right I/O, now we're back to doing the math on the RAID penalty. We're trying to figure out what our total amount of IOPS are. And we're trying to land a large amount of data and a large amount of IOPS. Similarly with our app delivery technology. Big fan of things like ThinApp and ZenApp and AppV to stream applications in. But I think it's important to recognize that we're changing the I/O profile of what our virtual desktop looks like. So if you bake, let's say, Office into your gold image, and you have a session tomorrow talking about, should I bake Office into my gold image or should I stream it in and how to do that? But if you're baking Office into your gold image, you're doing read I/O when you launch Office for the first time. If you're going to deploy it with something like AppV, well, when a user launches that, we're now bringing data down, albeit it's not the entire Office install, but we're now bringing data down to that virtual desktop, creating write I/O that we have to land somewhere. If lots of users are doing this all at once, you need to be taking this into account. You need to be essentially using tools to determine what that I/O profile looks like, because we have to land that data, and then we're going to go ahead and read it all, right, and launch the application and create a whole bunch more I/O. In building for write IOPS, what I see a lot of customers still doing are just adding spinning disk. It's very expensive, but it's a tried and true, proven method. If you're doing the math, you can absolutely add enough spinning disk to satisfy the disk load. Using solutions like I talked about before, like SSD tiering, doing that at a sub-1 level, so tiering blocks of data up that are being read more frequently. Most of those solutions also then use that top tier as where all the writes go, and then they trickle it down over time. But that provides us typically a larger landing area for our write IOPS on disk that can handle thousands of I/O per second versus a couple hundred. And then the other thing we talk a lot about, if you're doing a non-persistent virtual desktop, looking at solutions where we're using local disk, using spinning disk, using SSD, looking at solutions like Fusion I/O, things like that allow us to, instead of having a whole bunch of I/O go to a shared SAN, being able to land that I/O locally. But ultimately, all of these solutions are they're all expensive, right? Even doing local disk and a whole bunch of servers can be expensive depending on what you're trying to get from a VMs per host perspective, because that sometimes servers today aren't built with lots and lots of internal disk drives, although there are some out there. And then I/O optimization. So this is an area where we work actually with a few vendors that optimize the I/O, and that's one, I think, very clever way of being able to land a large amount of write I/O with what you're already using in your environment. So instead of writing lots of random writes to disk, we're serializing that data. We're, in many cases, I think dedupe is probably not a fair word, but in some cases they are deduping it. In other cases they're just compressing it and then writing that data sequentially to disk. And because it's sequential now, those spinning drives can handle significantly more write I/O than they were able to when it was completely random. So, but generally, what I worry about in an environment, I see a lot of vendors that advertise, how they are solving the boot storm. With my customers, boot storms are not the issue. Login storms are the issue. Login storms are definitely heavy on the read I/O, and they generate a lot of write I/O. But that's the issue that I find. And if you don't understand how the RAID penalties work, then you're kind of, I think, you don't understand the scope of the issue that you might be creating in your environment by choosing the wrong RAID type. And then back to figuring out what your read-write ratio is. If you don't know what the read-write ratio is, that's one part of the equation of the math. It's what type of RAID am I using, what percent is my read-write ratio, and what are my spinning disks that I'm using for that. So kind of a summary here as we talk about storage. You can see the difference here, in tweaking the RAID type we're using, and tweaking the read-write ratios we're using. It significantly impacts the amount of spinning disk that you require in your environment. Latency, it really is the key metric. Just like in the CPU world, at the end of the day, whatever magic the storage controller is doing, whatever the vendor is selling you, as long as it can satisfy a read or write request in under 20 milliseconds, hopefully even under 10 milliseconds, then you're good, right? But that's the number that if you exceed 20, it's time to stop, or your solution is going to fail. And then really write ops is the thing that causes issues, and it's the number one focus in doing a VDI deployment. So how does this relate to how to fail at VDI, right? And how am I tying this all back to how I see some of our customers struggling in deploying VDI solutions? I see a lot of people that go out and they do a pilot, and during the pilot the performance is great. Maybe that's because what they're trying to do is they got 5 virtual machines. Each one of them pretty much has a dedicated physical core available, and they say, yeah, you told me that voice wasn't going to work on my virtual desktop. It works just fine. Well, yeah, you've got dedicated physical cores available to you. That's not going to scale to 100 users, right? But if you understand how that compute layer works, I think it makes sense as to why that doesn't work. And definitely, if you look at where the industry is going, it is not to do things that are latency sensitive at that layer, and definitely not for voice. And so what I see is people have a great experience or an acceptable user experience in their pilot environment, but as they go to production, performance degrades. It's not linear, and it will fall off a cliff when you finally reach that breaking point. Boot storms versus login storms. Boot storms are read IOPS. I can land a lot of read IOPS. That's not a problem. I can use different caching technologies to do that. Login storms, however, generate more write I/O than they do, or they generate a lot of write I/O as well as a lot of read I/O. But the write I/O, depending on RAID penalties, can be very hard to land. So I worry more about login storms because that's something that I have to worry about. That's something I can't necessarily predict when the user is going to do that. Versus a boot storm I can do, in most of the environments we have that are very large, with the exception of a couple of verticals. They're doing their boots, in the middle of the night when nobody's around. So even when it is slow, it's not actually impacting users. Your application deployment strategy is going to impact the write I/O in your environment. If you're streaming things in after the fact, it's going to be even more important to understand how your users, when they launch applications, how you're maybe doing some of the pre-caching technologies on your gold image, right? Whether that's worth it to you, because you're generating write I/O when you stream these apps in. Do you actually hit on any of that stuff, where like the write I/O impact? Of course not. You're just like, stream it in. Who cares? Let the storage guy worry about it.
Pre-cache.
Pre-cache, yeah. And we see a lot of that too, because it can be a lot of I/O. If the first thing all your users do is launch the same application and you're streaming that in, that's a lot of write I/O to potentially land, depending on the size of your app and how much data needs to be pushed down to the desktop. So you're always making trade-offs, right? There's no people are always looking for that silver bullet. I'm like, it doesn't exist. Everything is a trade-off. Read-write ratio is extremely important. It's going to impact that math that we do for I/O calculation. Antivirus software. If you are not meeting with your antivirus vendor as you go to do a VDI solution, you're going to be in for a lot of hurt. We work a lot with vSphere as our hypervisor. Definitely that model is one where they're directing their antivirus vendors to integrate with them to use vShield, where we're doing a virtual appliance on the hypervisor and it's offloading all of the scanning. So as opposed to having 100 engines running, we're doing that with a single engine and using an API to access it. Other solutions, I think was it like McAfee that fell into this? I think they also now support vShield, but they were at least intelligent prior to that about how they scanned virtual desktops, so they would actually hash files. And if this desktop had already scanned XYZ file, another desktop on that same host or even in that same cluster wouldn't need to scan the same file again. Believe it or not, let's see, it was last Wednesday, talked to a college. They're doing 500 hosted virtual desktops. I asked them about their antivirus. They have scheduled scans every morning. So, there's really no way with the storage systems they're looking at that they're ever going to land the amount of I/O. And on top of it, they have no tools to actually tell them how much I/O that really is. But they have a performance issue, right? They're actually somebody who called us after they had already gone down this path. And then, using existing desktop images. If you're a vSphere administrator, you're not working with your desktop team, you're just capturing an image in. One problem I see with that is you don't really actually know what's in that desktop image. You're trusting whoever built that they knew what they were doing. And so, ultimately, I think, you need to be in control of those desktop images, and you're going to need to use some tools to get a deeper look at what's going on within those images. So, guessing. This is what people do. Ruben, he talked about this morning. If you were in his session, he talked about, how do I choose, VMware View or Citrix Zen Desktop? Flip a coin. When people say, well, how many VMs can I put on a host? If you don't have tools, you're flipping a coin. You're guessing. I have no idea. I have no idea what apps you use. There are people out there that just use the Office suite. We can probably take a educated guess at that one. But most organizations have their own internal applications. I've found many applications that generate significantly more write I/O than anybody ever thought they did, or a lot of read I/O. In some cases, the application was broken. In some cases, that's just the way it was. So we use tools to really determine what the initial sizing needs to look like. And then if you're a large organization, what I see happening in these environments, call centers is a good example where their software they're actually running is being brought into them by the customers they're selling their call center solution to. They really don't have any control over the apps that are coming into their environment. And for them, the tools are really not only about sizing out and understanding where the I/O is coming from today so they can build a solution that's going to fit, but over time, because they're getting at least one application change per week, they need to understand what the baseline is and how the updates that they're making to these applications is impacting that baseline, both from a compute and from a storage layer. So if they get a new app from one of their customers and now it takes twice as many CPU cycles, it has twice the compute impact, or maybe it's generating a lot more threads on the virtual CPUs, or maybe it's generating twice as much disk I/O, that they understand why their environment is changing. And for them, they're actually building their own, basically, kind of test environment that new applications move through, so they can use tools to determine the deviation from that baseline that they created from their initial sizing. And really that works into that whole monitoring application impact over time. So I used this in a slide about a year ago, and I thought it was appropriate because I was in the UK. So I have an old Land Rover, Range Rover, and what I have here for the people in the back, it's a picture of the cardboard box that's underneath that vehicle, and it's spotted with oil. And so for that vehicle, it leaks, right? That's normal. I relate that kind of back to you understand that this application is really write intensive, right? That's your baseline. If I were to pull out that cardboard and there was nothing on it, I know that I forgot to fill it up because I am completely out of oil, right? Leaking is normal for that vehicle. So with application updates, I think it's very important that we use tools to determine the change to the compute and the storage layer so that you can basically predict, forecast, not come in on Monday morning and find out that your compute layer is completely saturated, not come in on Monday morning and find out that your write I/O doubled, right? Or at least if you do find that out, that you can look at a per process basis and know where that I/O is coming from, and then use your RAID penalty and use your disk math to figure out what that new impact is to your environment, how many additional disks you need to add. And this is something I think is kind of unrealistic for people to do all of these things, but I think it's at least good that people understand when they're testing with 5 users that what they are not doing is performance and scalability testing. It's probably good to say out loud. It's probably good to tell your boss that as well. So when I hear people that say, well, what are your success criteria for doing this VDI project? Oh, well, we're going to test and see if we can access Windows 7 remotely from our home PC. Okay, that sounds like a unit test to me, right? There's no application testing going on. Unit testing is just making sure that the different components that are part of your VDI solution are working together. What I don't see happening a lot in most environments is performance and scalability testing. And I think that's really one of the core reasons why VDI fails, in conjunction with a lack of tools, is that we really don't know where the breaking point is. And because we're pushing the compute layer so much harder than we were before, because generally I think it's misunderstood how the compute layer works, And because people are just kind of glossing over the storage layer, that's where I see VDI failing, at least with our customers. And so, I think there's definitely a significant time investment if you're going to do performance and scalability testing. But I think it's good that you understand that if you're only testing with 5 users, that is not performance testing, and that that's not something you can extrapolate out to 100 users. Operational testing is failing. Maybe you take your controller and take it offline and make sure things load balance and everything works. That's typically done in most of the environments I'm in. And then user acceptance testing versus pilots. Are you writing out a set of things that you're actually testing in your environment, or are you just telling your users to connect and try to use the desktop? How strictly are you controlling the test? How much feedback are you getting? And then are you using tools at the same time to start determining impact to your environment so you can start at least doing some sizing for your VDI project? So kind of a summary in this for this whole session is, my goal really when I go and talk to our customers about VDI or about any of this technology is, because I think once you understand, some of the challenges with VDI, and many times, people are saying, okay, well, maybe I should start looking at a shared solution on top of RDS or on top of XenApp or on top of a Quest software solution for that. Once you start seeing some of the challenges at the compute layer, some of the I/O that's being generated from a VDI solution, I think that really opens people's eyes once they understand the impact to those two resources. Because I think people, in many cases, at least the ones I'm talking to, they gloss over it and they assume that they are unlimited, and they don't understand how some of that compute scheduling is actually being done. Secondly, don't guess. Use tools. I understand that tools cost money, but ultimately I believe that they're going to save you money, and they're going to allow you to be successful in rolling out a solution, because you're going to understand where the load is coming from, how that load is changing over time. And then 5 users, and I keep going back to it because I keep hearing it over and over again, is we're going to put 5 users on this thing, right? And if it works on that, then it'll work with 100, and it doesn't. But if you're going to do it with 5 users, make sure that you understand what kind of testing that really is. Maybe that's system testing, or maybe you're doing some user acceptance testing with 5 users, but you're not doing performance testing, you're not doing scalability testing. So thank you for coming. Hope you enjoyed your first day at BriForum. Any questions?
So what tools do you recommend or use yourself?
Yeah. We've used Lanamark, we've used Lakeside, taken a close look at Centrix. Liquidware has a solution in that space. I don't know that I do enough of this hands-on. I've got delivery people that do the majority of that analysis, and they're probably the best ones really to give that kind of feedback. But at the end of the day, all of those tools will give you more information than what you have today. They'll allow you to at least understand, within the virtual machine, where is the disk I/O coming from? Where is the CPU utilization coming from? And better than 50% of the time, there's something in there that you were not expecting. And if you can, change that, then that's going to drive, maybe up the number of users per host, or drive, down the amount of IOPS per desktop. But at the but we really have to get more information about those desktops if we're going to do any type of planning, and therefore be successful. So, how many people in here are users of Lakeside, Lanamark, Liquidware, Centrix? And Liquidware. Yeah. Sorry, one person. I'm certain there's somebody else here who's using it, but. Any other questions?
What's a good value of percentage of users you should be using for testing, or should you go with the number of users to fully load one of your servers?
So I would say, what kind of testing do you actually want to do? If it really is scalability testing, then you should be testing with the number of users that you are hoping to put on that host. Yeah. Yeah.
But how do you convince a customer to spend the money to test that many users without?
Yep. Bingo.
Yeah.
It's difficult. It is difficult, but I guess that's part of the challenge with VDI is, The only way you're actually going to know is to buy. You can buy tools like Login VSI and simulate workload, but unless you have a really good idea of how users are using applications, it's still going to be difficult. Or like View Planner, or EdgeSite for load testing, it's still going to be difficult because I think we have a very difficult time, and actually we don't know what our users do, right? I mean, my IT department surely has no idea what I do, and what applications I even use for that matter. But I mean, if you're really going to be accurate, then you would try to test with the number of users per host that you would be expecting to get. And I think the other thing that I don't know, there's some other consultants here in the room, but the other thing I see coming on the horizon is we're going from 1 virtual CPU to 2, and that is going to create contention on those physical cores. You're either going to have to bring down the number of virtual machines on that host, or add more physical cores. So Intel helps us out a little bit here. They keep adding more, cores per host, but there's contention for physical resources. Because VMs, whether users are really doing anything on it or not, the operating system is doing work all the time, and I see high percent ready values kind of often, and utilization numbers are 40, 50%. Even our own IT department at the company I came from, I mean, they didn't know. It was just servers even, and it wasn't that many servers, but they'd gone and put a few too many virtual CPUs on a couple VMs, and just generally had a little bit older hardware they were working with, like a couple generations, and high percent ready values, and they really didn't know it. See, I look at a company like that that's going to go and try to do desktop virtualization, and without that understanding, what they're going to see is, well, this sucked, right? This didn't work. The reality is they need to know, well, is that a storage issue? Is that a compute issue? Is that something else? And the information's all there.
Okay, Dan, thank you very much.